Hello everyone, welcome back to one more small session. In this session, I'm going to talk about Chargaff's rules, particularly the application type of questions will be asked in your NEET based on Chargaff's rules. For example, the question will be like this: in 100 kilo base pairs DNA or 100 kb DNA, the percentage of adenine is 15%. What is the percentage of guanine? Simple, it's very easy. If you follow Chargaff's rules, you can easily calculate it. That is, the percentage of adenine is always equal to the percentage of thymine. What is the value they have given in the question? That is 15%. They have mentioned it, the adenine is 15%. What is remaining now? 85%. That means thymine is always equal to adenine, or adenine is always equal to thymine. We know it in a DNA. If you look into the double stranded DNA model, always adenine binds to thymine with the help of two hydrogen bonds. Whatever the number of adenine is present, the same number of thymine should be present in the DNA. So the percentage is also 15%. That's it. Now the 15 plus 15, that is 30%, is occupied by adenine and thymine. So remaining is 70%. So 70 divided by 1, 2. 70 divided by 2, that is 35%. So guanine is 35%. Cytosine is also 35% because the guanine, the total number of guanine present in a DNA molecule is equal to the total number of cytosine molecules present in the DNA. That's it. So this is it. Very simple, right? So this is the thing. The percentage of adenine is always equal to thymine. The percentage of guanine is always equal to cytosine. No need to be confused here because I have used looks like the two hydrogen bonds. No, this is equals. This is equals, but we know that adenine always binds to thymine with the help of two hydrogen bonds, that is 2H, whereas guanine is always binds to cytosine with the help of 3H. Here the basic is to break the bond, to break the hydrogen bonds. For adenine and thymine, the less amount of temperature is required. Let us assume that 50 degree is enough to break the bond between adenine and thymine. But when it comes to guanine and cytosine, because it contains 3 hydrogen bonds, it is like it requires more temperature to break. We will talk about that later. So that means if a DNA sequence has more number of guanine and cytosine, like guanine, cytosine, wherever somewhere else adenine and thymine comes in between that. But if you look into the total number, the guanine and cytosine is more, then obviously the DNA is stronger. It requires more temperature to break that particular DNA. This is it. If adenine and thymine is more in the DNA, if it is rich, we call it as AT rich DNA. Whereas GC rich DNA. That's it. Got it? So if AT is more, then obviously less temperature is required to break it. Okay? Denaturation. Next is, according to Chargaff, he says that A plus G by C plus T equal to 1. It is always constant. A plus G equal to C plus T. So here we have a purine. So this is the purine and this is also purine. And this is the pyrimidine. This is the pyrimidine. Suppose if A is, let us assume that 15, G is 35. What is the total number? The purine in the particular DNA sequence is 50. But it is one thing is sure that the adenine value cannot be equal to guanine, even though both are purines. It varies. But for adenine, the thymine value should be always 50 because they bind. For C, the G value is 35, so for C it is 35. So that is 50 equal to 50. That's it. So purines equal to pyrimidines in a DNA. That's it. Got it? So doesn't matter what is the total number of a particular purine is present. The number should be equal when it compares to the pyrimidine. Purine equal to pyrimidine. That's it. Okay. So doesn't matter with the individual purines like adenine number or guanine number. So when you equal it, it should be 50, 50. This is one example. Next is A plus T or by G plus C, which is constant for a species. Let us imagine that in my body, in my genome, that is the total number of adenine is, let us just assume that 2.5 million and T should be exactly same, 2.5 million, correct? And if you know the value of this, it's very easy. Let us assume that the guanine is 2 millions, whereas cytosine should be same, 2 million. Now just that is 5 by 4. So 5 by 4, that is approximately 1.2. But for a human, the value of the Chargaff, that is constant for a species, the value is 1.52. Remember, very important. You may get a question. So what is the Chargaff rule constant for a particular species, that is human being? For human being it is 1.52. For E. coli or Escherichia coli, which is a bacteria, which is lesser than human, because the DNA is smaller compared to human DNA, correct? So it is smaller, 0.92. That's it. So this is all about Chargaff's rules. So we learned about it. Just focus on another small concept, which is not that important for your board examination, but for NEET could be asked. At least for knowledge you will learn it. What is C value, or what is C value paradox? See, I have not written value paradox. C value is the amount of DNA present in an organism. What is the total or amount of DNA present in my body? I mean a particular organism, right? It normally actually constant for a particular species. So it is the total or amount of DNA present in a particular organism. That's it. So what is the total amount of DNA present in the organism? How do you calculate the total amount of DNA? Very simple. Just you have to pull the entire DNA from a particular cell of an organism, and then you see count the total number of nitrogenous base pairs. That's it. So based on the nitrogenous base pair number, you can say that whether the DNA in a particular organism is high or less. So if you have more DNA, or the amount of DNA is very high in your body, obviously you are a complex organism. See, human beings have very high C value. They have more amount of DNA compared to other organisms. So our body is bit complex. So more the amount of DNA, it increases the complexity of an organism. That's it. Complexity, hope you know it. See, eyes particularly for vision, and ear is particularly for hearing. That's it. Or maybe mouth is for talking, eating, whatever it is. Correct. So it varies, and the function also more in a particular organism. C value paradox. What is it? It is the difference between the complexity of an organism, with the amount of DNA presenting. That's it. So you are just comparing the complexity of an organism with the amount of DNA in the organism. For example, see, if we just consider one particular organism, that is the salamander. In salamander, the C value is very high. It has got a high amount of DNA in it. When we compare humans with the salamanders, the C value is lesser in humans compared to salamanders. This is weird, correct? So I'm just comparing the C value between human being and salamander. Salamander is a tiny organism. Let us say, like, compared to human, it's very small. Whereas human is a big organism with different functions compared to salamander. But the amount of DNA in salamander is very high, whereas in human it is less. So it is C value paradox. It is a kind of error in manufacture. Correct? It's a bit of error, right? For us, like, the C value should have been high because we are more complex organism. For salamander, the C value should have been lesser because it is a simple organism. But in this case, it is different. That difference in the complexity of an organism versus the amount of DNA which is present within that organism, that is called as C value paradox. Hope you understood what is C value. That is the amount of DNA present in an organism. Whereas C value paradox is the error, that is the complexity versus the amount of DNA. That's it. So that's all about these two things. Hope you understood this. Could be asked in NEET. I'm not sure about it, but just learn it, at least for the knowledge.